Good morning, students. Today we are going to discuss about software maintenance. So we know that this is the last phase of SDLC. Once we have developed and deployed our software and it is under the operational phase, then if any change is required due to some or the other reason, we call for maintenance. So just go through it briefly. Software maintenance is the process of modifying the software product after it has been delivered to the customer. The main purpose of software maintenance is to modify and update software application after delivery to correct faults or to improve the performance. So there can be different reasons for which the change is required or modification is required. Based on that, software maintenance is divided into various categories that we have already discussed. Right? Prior to this, we'll be discussing why maintenance is required. What exactly is the need in order to correct the faults? If your system has any fault, it's not working properly, definitely we call for maintenance. To improve the design, implement enhancements, that is adding new features to your system, interface with other systems, accommodate programs so that different hardware, software, system features, and telecommunication facilities can be used, ultimately updating and enhancing your system with respect to these all things. Then migrate legacy software. Legacy softwares are the very old softwares which lack proper documentation. We just have the code and we doesn't have any other thing like designing or requirement. Nothing has been carried out. So this is what migrating the legacy software is. If you have an earlier software, very old software whose only code is present, so from that code you have to get all the phases, previous phases. From the code you will identify the design, from design you will identify the requirement, and then if you want to add new features or enhance your system, so from the requirements that you have retrieved, in that you will modify or add new features, and again you will carry forward SDLC to develop your system. So we'll see how this migration of legacy system takes place with the help of process model 2 in the last slide. That is reverse engineering and forward engineering is taking place there. Then for retiring the software, we doesn't want our software to retire, actually we want to prevent it from getting obsolete, right? So this is what the need of maintenance is. Few reasons. Then the types of software maintenance. The first one is a corrective maintenance. Whenever there is an error or a fault in your system, you go for corrective measures. This is known as corrective maintenance. Adaptive maintenance is whenever there is a change in a platform or new operating system comes in, right? Or new hardware or a software is there. So in that case, you have to adapt to that change. Then perfective maintenance is to make your system more perfect by adding or enhancing your system, right? So you can add new features, you can add enhance the performance of your system, right? There can be several reasons where you can go for modification. Then preventive maintenance is to prevent any of this could take place, or finally we want to prevent our system from getting obsolete by making frequent changes. So these are the few types of maintenance. So this is what we have already done in the first unit while we were discussing about the SDLC phases. So what is important now here is the reverse engineering. So we'll be having few terms like reverse engineering, forward engineering, and re-engineering. That is important with respect to maintenance. So let's see first of all what is reverse engineering is. So reverse engineering is the process of recovering the design and requirement specification of a product from an analysis of its code. Remember I said in legacy software are the very old softwares where just only code is present, and you have to fetch the design or generate the design and requirement by analyzing this code. So it is a part of reverse engineering. Reverse engineering is becoming important since several existing software products lack proper documentation, are highly unstructured, or their structure has degraded due to a series of maintenance efforts. So, by reverse engineering, providing proper system documentation, recovery of the lost information, assisting with maintenance, facility of software reuse. This is important. We have to reuse our software. and discovering unexpected flaws or fault. So what, see this diagrammatically, a good way to represent. We just have the code. From this code, we identify the module specification. Modules are what? The functions which are present in your code. So we get what are these modules actually doing. We get out the specification. So from that module specification, we prepare the design, and from design we get the requirement specification. So this is a reverse process of SDLC. SDLC is this: requirement, design, module specification and code. But we are moving in an upward direction. That is a reverse. That is why it is known as reverse engineering. Next. Now we have two process models which helps in maintenance. Right? The first process model is like, see here, this is a process model 1, which is a direct or a forward approach. In say you want to change something in your software, the first step is gather the change requirement. Okay, what change has to be implemented, get all those change requirements. Then analyze the change requirement. Analyze for what? Okay, what is the change? What will be the impact of that change? Will it be effective or not? And what changes will be, once you are going to make this change, how it is going to impact other parts of your system. So this is what needs to be analyzed. When you analyze these change requirements, devise code change strategy. Now you have to make the relevant changes at the desired location where the change has to be implemented. So identify that strategy, how you're going to make the change so that it has minimum impact on other modules, right? Then apply code change strategy to the old code. So whatever code you have identified the strategy, now apply all those changes. Once you apply the changes, there are two set of activities that needs to be carried out. The first one is update the relevant document. You know that in the software we have document for each and every phase. So whenever you make the change, you have to modify those documents also. It must be in sync with the modified code. Along with this, since you have made the changes, you have to integrate and test it also. So integrate with the existing system and then test whether it is working well or not. So this is a direct approach or maintenance process model 1, which is the simpler one, right? You have the change requirements, you analyze it, you devise the strategy for the change and you apply it, and you update the document, integrate and test it. While we have a process model 2, which is representing a re-engineering. Re-engineering constitutes of two parts. One is a reverse engineering part and another is a forward engineering part, right? So this represents the re-engineering, maintenance process model 2. Now, where it is applicable, I said generally it is applicable in legacy softwares where we have very old softwares where only code is present, right? And you want to retrieve all the relevant documents and then you want to change the requirements there or modify it, and then you apply the forward engineering to modify it. So how it works? First, see, this is a reverse engineering part. You just have the code. From the code you get the specification of the module, you get the design, and then you identify the requirement specification. Then now say you want to enhance it, you have some change requirement. So now you have the requirements here, modify those requirements as per the change request. Then get or prepare the design for those change requirements or the complete set of requirements. Then get the module specification and accordingly develop the code. So this is forward engineering and this is backward or reverse engineering. Altogether this constitutes re-engineering process. So that's all for today. This was a simple topic. Hope this is clear to all.